Hi everyone, this is video number 1 for, so I'm going to write video number 1 for section 9.3, part 1. Okay, so in section 9.3, we take the trig functions that you learned in section 9.1, and we take the angle drawing that you learned in section 9.2, and we put them together to help us find the trig functions for certain angles, not just for a triangle. So take a moment, maybe pause the video and fill in these vocabulary words, and then I will talk through them a bit here. So it says let theta be an angle in standard position. And remember, an angle in standard position just means I put my angle on the coordinate grid here with your x and y axis. So here's my angle that I drew right here. Standard position just means you're putting it on the x and y axis. Now what we're adding here is we're going to put a coordinate point. We're going to give you a coordinate point. So that's the xy. And you'll notice it's going to be on the terminal, or you can think at the end of the terminal side of my angle. And then we have this circle drawn here. We're going to talk a lot more about the circle in 9.3 part 2. But for now, just know we are overlaying a circle on the coordinate grid. And the circle is going to have a radius of 1. So this point right here is 1, 0, because this radius is 1 all the way around. So the way this works is it's actually kind of cool when you're given this coordinate point. If you peek ahead at this example down here, here's an example with the coordinate point. I can find my trig functions right from my x and y values of my coordinate points. So for example, sine is going to be y over r. Now r is the radius. The radius is going to change depending on what your coordinate point is. So I want you to add, let's say up here, the equation for r is this. Again, I can get my r right from my coordinate point. So r is going to be the square root of x squared plus y squared. This should look familiar. This comes directly from c squared equals a squared plus b squared. This comes directly from Pythagorean theorem. So r is the same as your hypotenuse in a triangle, and I'll show you more of that when we get going. So you can write these here. Sine is going to come from y over r. Cosine is going to come from x over r. Tangent is going to be y over x. Remember, the partners are just the reciprocal. So cosecant is going to be r over y. Secant is going to be the reciprocal of cosine. So that's going to be r over x. Cotangent is the reciprocal of tangent. So that's going to be x over y. Again, pause if you need to fill this information in, because I'm going to get right to example 1. Okay, so here we are in example 1. I'm going to fill in this here. And so when we get to those, we know what we need. So x and y is given to us. It's right there. X is 5, y is 12. Let's find r. So r is going to be equal to square root of x squared plus y squared. Square root of x squared plus y squared. X is 5, y is 12. Okay, so what I get here is r is equal to the square root of 169. 25 plus 144 is 169. 169 is a perfect square, so I'm going to simplify that one step further. If you put this in the calculator, the square root of 169 is 13. You're going to get a nice whole number. When it's a perfect square, we want to simplify it down to that nice whole number. So now I know x, y, and r, so I can find my sine, cosine, and tangent. So sine is y over r. Y is 12, r is 13. So sine is 12 over 13. Cosine is x over r. X is 5, r is 13. Tangent is y over x. I don't even need the r. Y over x, 12 over 5. Okay, now let's do the partners. Sine is 12 over 13, so cosecant is 13 over 12. Flip it or take the reciprocal. Cosine of theta is 5 over 13. Secant of theta is going to be 13 over 5. Tangent of theta is 12 over 5. Cotangent is going to be 5 over 12. Okay? Not too bad, huh? I'm going to do one more. I'm going to show you that what we did over here. If you like it, awesome, you can go with it. I'm also going to show you how we can create a triangle, and then you could, if you prefer, you could use your SOHCAHTOA to find your trig functions, just like we did in 9-1. So here is my angle. Here is my x and y. What I'm going to do is turn this angle into a triangle. Now, the one thing you have to, that's very important, is when you make your triangle, it must every single time touch the x-axis here. So I drew that triangle. I'm making the third edge of my triangle going straight up till I touch the x-axis, and that's going to be a right angle. This would not be correct because that is touching the y-axis. So your triangle must touch the x-axis all the time. And then this theta that's measured here, what I'm going to do is, here's my triangle. There's my triangle. My theta is going to be right here in the corner. So when you draw these triangles and you add your theta, I always say theta is snuggled up right here next to the origin. So theta always likes to be snuggled up next to the origin. So I'm going to show you, for example, down here. Start from your coordinate point, draw the third side of your triangle down to the x-axis. There's my right angle. My theta is going to be right there in the corner, snuggled up by the origin. Now, if this is my theta, here's my right angle. So this is my hypotenuse. This is the side that touches my angle. So this is my adjacent side. And this over here is opposite. So that would be my opposite side. So my sine is going to be opposite over hypotenuse. Sine is opposite over hypotenuse. Now we need some numbers on here. If you think about this, plotting this point, -4, -3, I start at the origin, I go over to the left, -4, and down -3. That's how you plot that coordinate point. Well, if I start here and go over -4, that means this side of my triangle, hopefully you can see that, this distance here is -4. And then I went down -3, so my opposite side is -3. My hypotenuse, guess what? I can use the same formula because hypotenuse and r, or my radius, are the same. So remember, it was x squared plus y squared inside the square root. So I'd have -4 squared plus -3 squared. Now notice I wrapped these numbers up in parentheses. When you have negatives, you have to wrap them up in parentheses. So make sure you do that. So 4 squared plus -4 squared plus -3 squared gets me 25. If you punch that in the calculator, that's 16 plus 9. This is, again, a perfect square, so the square root of 25 is 5. So my R and my H are 5. So I'll just show you that I can use my opposite over hypotenuse. There's theta. Opposite is -3. Hypotenuse is, let's fill that in, 5. So opposite over hypotenuse would be -3/5. Back here we said sine is y over r. Well, notice, here's x, here's y. Y is -3, r is 5. Y over r is -3/5 also. So opposite over hypotenuse and y over r give you the same thing. So if you liked what we did in 9-1 and you like the triangle, you like the SOHCAHTOA, you don't want to learn this new y over r, x over r, you can stick with this. You can draw a triangle, draw your theta right in the middle by the origin, do your opposite over hypotenuse or adjacent over hypotenuse. So here's theta, here's adjacent is -4 for cosine, hypotenuse again is 5, or x is -4, r is 5. So either one. Tangent here was y over x. Y over x is -3 over -4. Now this one, 2 negatives in a fraction make a positive. So negative divided by a negative is a positive. So you need to simplify that one more step and make that a positive. One negative is fine. 2 negatives, you have to make that a positive. Just trying my light to see if it helps. Okay, cosecant is partner with sine, so I want to take -3/5 and flip it, make it -5/3. Doesn't matter where you put that negative. You can put it with the numerator, with the denominator, or even out front. -4/5 becomes -5/4. Secant and cosine are partners, so that's the reciprocal of cosine. Cotangent, take your tangent and flip it. Okay? I'll tell you what, I would like you to try this one. This is x and y. I'll do the first part with you where we find the r, because for this one it's a little different. So there's our formula, x² + y². So in this problem, x is -2. Ooh, that's a negative. Wrap it up. Y is 3, not a negative. I don't need to wrap that up. This is 4. This is 9. 9 + 4 is 13. Now, if you put square root of 13 in your calculator, you're going to get a decimal. We don't want decimals. So just leave your r in the square root. So r is going to be the square root of 13. So sine, which is y over r, y is 3. That's going to be 3 over the square root of 13. Cosecant is going to be the reciprocal. So I'd like you to pause the video and try to finish this, and then come start the video back up and check it. Okay, hopefully that is what you got. One more thing I want to mention before I end this video is all of our fractions or ratios that we had here were already simplified, but you need to simplify fractions. I'm going to add it here. You should too. So for instance, say you did sine of theta and you got 8/10. You want to reduce that or simplify that fraction. So 2 goes into 8 4 times, 2 goes into 10 5 times. So make sure your fractions are fully simplified when you're doing this or when you do your practice. That is it for 9-3 part 1.